All right, so this time I'm going to do the upside down. So I started from Pacha. Yeah. Oh. Huh? Also, Nan is going to do the presentation today. Okay, then did you upload your data file? Oh, okay. Oh, this is the data file. Okay, sure. Okay, then I'll download it. Sorry. Hmm? How can I download it? Oh, here. All right. So, okay. Nan, come here. Show the data first, then describe in details how do you collect the data. Okay, then explain all the assignments. Okay, thank you. Where do I sit? Over here? Over there? Maybe here. Just a second. I'm using the microphone.
Good morning, everyone. Today I will present the assignment 2 of regression analysis. The data that I get from Thailand, I contact with my friend. She is the teacher in School of Thailand. So I have the observation for 50%, and I correct the data about the height and weight and the male. So
All of them are male. Let me see the gender.
yes, gender. For the
No, we need to have two genders.
Yes.
One is male, the other one is female.
yes. For male,
Okay.
I ask 1, and female I ask 0.
Let me see your data. So starting from 18 are male or female.
18,
1 stands for
1 still.
male.
Yes.
Okay, 1 stands for male and 0 is female.
Yes.
Okay, let me enlarge it. Okay, I have a problem to see it. Enlarge it. Okay, then what's the measurement of this? What's the measurement units? Measurement units. What's the height? 25 means.
25. I collect the data from the centimeter and
Centimeters.
yes,
Okay,
centimeter.
above 150.
Yeah.
So this is in centimeters.
Yes. Minus
Huh?
minus minus 150.
So the 25 means it's 175 centimeters in ninth grade. Does that make sense? Yeah.
There's a 238, and I'm not sure, maybe it's supposed to be 20 or 22.
Which one?
7.
Seventh. There's two.
Yes.
Yeah. So this means 2 centimeters. So
Yeah.
the height is 152
Yes.
centimeters. So those height is above 150 centimeters. So I mean that 25 is ninth grade students with 175 centimeters. Does that make sense? Makes sense.
And it's supposed not to be higher than 1 meter 80, right?
Higher,
Can it be higher than 180?
sure, if it is that tall, no problem with it. Okay, so let me see the rest of the data. Roll down, roll down. Roll down it, roll down it. What is the average height for a ninth grade student, which is already in 15 years old, right? So it makes sense. Okay, all makes sense. Okay, how about this? I mean weight.
Yeah.
This is in
and kilogram.
kilometers, right? Kilograms, right? Not kilometers. I'm sorry. Kilograms, okay? So, all right. All right, that makes sense. Okay. And I need two sets of measurement, right? One is for centimeters and kilograms. The other one is in inches and pounds. And what is the other set? I mean the data set. You need to have two data sets, right? One is in centimeters and kilogram. The other one is in inches and pounds. Two data set. So what the other one? You didn't do it? You just do one set.
Yes.
I think I put it in the assignments. I stated two sets of the measurement units. Did you read that? Did you all read that? Huh? I need to have two data sets. One is the measurement units for height is centimeters, which is above 150. The other one is in kilogram. Okay? The other set is in inches.
And I only did kilogram and centimeter. What I understood is that we can choose whether we...
No, you need to both. I want to compare the result.
But it's the same values, just in another...
Yeah. That's why I wanted to use that data set to show the difference. To show the similarities and the difference.
I don't get it because it's the same height, whether you use centimeters or inches, right? So I don't get...
I'll let you know the result. Okay, I'll let you know the difference and the similarities, okay? All right? Okay, which group do the both? Okay, all right. So Sylvie, okay, would you do the first? I'm sorry. Okay, I need to have two sets. of measurement units. Okay, this is what I'm saying. Okay, I'm sorry. Did you all see what I put in the let me see. Did you all see the announcements? Did you see this one? Then what do I say? Didn't I say it clearly? Let's read this one. Okay. Do I have any English problems? Did I show it, clearly? Collect the data of sample size at least 50 by yourself of every group. Okay? Then two required sets of measurement units for weight height, or in kilogram, centimeters. This is y, right? This is x. Above 150 centimeters, and pounds and inches above 5 feet. Two required sets of measurement units. Then do the labs questions step by step. Okay? All right, so yours will be so it's silver. Okay, download that. Click it. Okay, click it. Okay, let's just do it here. Okay.
Okay, good morning, everyone. This is our data that we have collected before, and the range is from 25 until 40 years, and we just have to collect the range of the height is from 155 until 190 centimeter. So this is the data that we have collected. Yeah, you can see. So this is for the centimeter, and the weight is for kilograms. And this is the gender. And we have the comparison as Prof. Cao required, that we have to measurement in inch and the pounds. And we just have to collect the data above the 150 centimeter. I move to okay, this is the data. And this is the data comparison with the measurement. And step 2 is calculate summary statistic. So the height, the mean is 169.94. The minimum is from 155 until 190 centimeters. This is the mean, it's the measurements. And after we run the regression, we have the equation. The first one is from, the measurement is centimeter and kilogram. So the weight that we get is 44.77 plus 1 height. And this is for the measurement inch and pounds. The weight is pounds and the height is inch about 5 feet. 5 feet is mean that 60 inch. So we get the weight. The equation is 100.103.77 plus 5.59 height.
This one is with pounds and, I'm sorry, this one is with pounds and
Inches.
inches.
Yes.
Pounds and inches, okay? The coefficient is 5.59, okay? Then this is in kilograms
and inch.
okay, kilogram and inches. Okay,
Yes.
so the measurement units is, in different measurement units is in Y or X. Pounds and kilograms. One is in pounds, one is in kilogram, right?
Yes.
So the difference is in Y or in X? In Y. Okay? The difference is in Y. So in other words, while you are doing the presentation, I like to also explain the difference or your expectation, right? Okay? So in other words, let me show. So if I say the original is Y, beta 0 plus beta 1 X. So this one is pounds. Okay? And we have the same X, right? So I just put this is Y1. And the other one is Y2. Y2. And beta, let me use the different notation of these coefficients, okay? So this will be going to be alpha 0, okay? Then alpha 1 X plus epsilon 2. So did you see the difference? This is X is in inches, right? And this is in kilograms, okay? And this is also in inches. So we have the different Y. And in other words, since 1 kilograms equal to 2.2 pounds, okay? So Y1 is going to be equal to what? In terms of Y2 this is pounds, right? This is pounds. This is in kilogram. 1 kilogram equal to 2.2 pounds. So this 2.2 Y2 equal to Y1. Am I right?
Yes.
Understand what I'm saying here? Okay, so if you do the comparisons, you need to see all the same Y2. Okay? All right? Y1 equal to 2.2 Y2. And this is Y2. Therefore, what's the difference? What's the difference between, we do have another one, right? If we don't, we have the question, is one with D, the other one's without D. Okay, so let me explain the one, alpha 2D. Okay, what do you expect? The relationship between alpha 1 and beta 1. I have the same Y, but I different. Same X, but different Y. This one is 2.2 times y2. So in math, just thinking about in math, okay, now my y2 from this models, this y1 is equal to 2.2 times y2. So what do you expect the coefficient, alpha 0, alpha 1 and beta 1? So from the report, kilogram is this, right? This is kilogram, okay? The coefficient is 2.54. So this one is 2.54. And how do you expect the beta one? So this one is beta one, right?
Yes.
Right? How do you expect the beta one? Since this y1 equal to 2.2 times y2, therefore, beta 1 should be equal to 2.54 times 2.2.
Yes.
Check it. Is this one equal to this one? I mean, equal to this one times 2.2? Yes. In other words, you can do the comparison by yourself. And does that follow your expectation?
Yes.
That's why we need to do the comparisons. Understand what I'm saying here, Evan?
Yes, makes sense.
Yeah, okay.
Well, it's E and the same.
You mean,
Well, the constant have the same.
oh, you mean the constant. How do you think? I need to multiply every one of the coefficient. So how about this one? This one is 47 something. Would you please do it for me? Times 2.2. This one will be equal to this one. So constant term as well. Okay? Then, this is very, very important parts, okay? We're just talking about the coefficient. Then I like to also mention standard error. Okay? This one, we're going to talk about this in chapter 4. And when you do this concept in chapter 5, which is the hypothesis testing, okay? You need to understand those relationships in order to know the rest of parts here. This is really important in chapter 5, and this is the core parts in this semester, in this course. Okay? So look at this one. Did you see, since this one multiplied 2.2 becomes to this one, okay? And look at the standard error. Is there any change of the standard error? Does the relationship exist in standard error as well as the coefficient? Look at this one. This one, standard error. And the standard error, this is also 2.2 times. Check it. Yes, right? Okay? And, we are not talking about T statistic yet until chapter 4 and chapter 5. Okay? Since this numbers is equal to this one divided by this one. Okay, I'll talk about that later on. Those t values equal to this coefficients divided by standard error. Therefore, this one multiplied by 2.54, 2.2, right? And this one is also 2.2. Therefore, when I divided these two terms it becomes the same as t statistic. So did you see this one and this one are exactly the same thing? You all see that? This is why when we do the different measurement, actually, this is the same data set. I should have exactly the same conclusions. Okay? Although those coefficient and also standard error are different, but in certain relationship. But all the hypothesis testing, when we do the hypothesis testing, is to see whether these factors are, have the statistically significant impact to the y variables. And the result for significance will not change because this is just the same data set. However, the coefficient will be different. You see the points? And this is what we also describe in maybe chapter 2 or chapter 3. When we change the measurement units, the coefficients changed. But the significance of the factors will not change. You see the points here? So by using these comparisons, automatically I can check whether your result is correct or not. Okay? And so this one is, okay, this one is using,
Centimeter.
This
is a centimeter and
okay,
kilogram.
this is different x, right? These two are the same x, different y, but
Yes.
this one is the different x. Okay, if I comparison this kg here, kilogram, what's the kg? Means I have the same y, but different x, right? So in other words, we have the same y, so which is kg, right? So I'm using this one as a kg, okay? So now I have another one, y2, okay, equal to, I like to use another notations for the coefficient. Then I have become x2, x1, because I have different x, right? And gamma 2d. Now the difference, this is in centimeters, okay? Okay, what do you expect? If I do the same y, but different x, okay, what's the relationship between centimeters and inches? So what's the relationship between x and x1? So x1 will be equal to 2 times 54x. Okay? So what do you expect? This one is 2 times 54x. So I replace this one with 2 times 54. So what's the relationship between the alpha 1 and gamma 1? I mean, reduce or increase. What's the gamma 1? Increase or decrease? x1 now is 254. So this one is x, and this one replaced to 2.54x. So how do you think the gamma 1 is reduce or increase? Let's see the result, okay? This one is 2.54. Okay, so this one is where? It's this one, right? It's this one. And I'm using this one in terms of this one. So gamma 1 becomes to
Decrease. 1.
smaller. It's smaller. Why?
Divided.
I need to use this one divided by 2.54 in order to be equal, right? Okay? You understand what I'm saying here? This is not, not difficult math. Okay, just do the comparison only. That's why, we need to thinking about if we have different measurement units, the coefficient can be changed.
It's a good way to influence your results.
It's a good way to what?
Influence your results.
That's right. If you see the result, especially for coefficients, sometimes we're using some kind of measurement units and it becomes the coefficient very small. And it's hard to do the explanation. Okay? In other words, you can change the measurement units. Sometimes larger, sometimes smaller, in order to change the coefficient numbers. But the total, the final result won't be changed. It won't affect the statistical result, but only make the coefficient looks nicer. Isn't that it's a good way to do it, especially for your final result. Okay? All right? Okay, so it seems that pretty good, okay? I know this result is correct. And would you please show, okay, continue, okay? So this is just the step 3. I like to explain this one, while you're working on these problems. So if I can correct you or I can explain it immediately, I think you have the vivid, understanding by yourself. Okay, and it is hard to just, put all of them together and give you the general conclusions, which, you all forgot everything. I am a student before, so I know how to learn it and how to learn it faster and also effectively. Okay? Make sure you understand the core parts, what I always mention in the class. Okay? All right. Continue.
Okay, this is for the step 4 that we have to interpret the estimate coefficients. And same with Prof. Gao already explained to us that the height will increase by 1 centimeter, the weight will increase by 1 kilogram. And this is and we have to compare with the equation 2.6. If the height increased by 1 inch, the weight will increase by 6.38 pounds. And in comparison with our data set, both equations have the same positive relationship, while the number of the intercept and the coefficient heights have slightly different. The possible cause could be the difference range of our data sets. So this is for the minimal and maximal from equation 2.6, and this is minimum and maximum from our data sets. And this is already Prof. Gao explained to us that we also compare the data from the same weight and different height. So the 1 centimeter equal to 2.54 inch. And this is for the step 5, interpret the R square. R square equals to 0.61. From the result, and this is the graphic for the R square from the equation. We just to use the measurement 150 centimeter and the weight is kilogram. So from the result above, the R square shows in amount 0.61, which approximately around 60% from the variation in weight can be explained by the Higgs variable, whereas the 40% from the variation weight could not be explained by Higgs variable. And this is for the step 6 to estimate a second equation that we have to add the gender from the equation. Our hypothesis is both variable Higgs and gender have positive relationship or increase with the value of weight. And this is the equation. So the result is the weight will increase by 0.84 kilogram if the Higgs increase by 1 centimeter, holding constant the gender variable. And the weight will increase by 4.55 kilogram if the participant is male and holding constant is the Higgs variable. And the other one we used to pounds and inches. And this is the result. So does the imply that gender has no relationship to weight? No, based on our result above, variable gender has relationship with weight. Both of the variable have positive relationship with the same with our hypothesis. The variable cannot be compared directly as the measurement unit are not same and the scale range is too wide. Hence, we need to investigate further to prove whether the variable gender is statistically significant or not.
Let me see the result, okay? Let me see the
Okay.
result reports. Okay? Let me see the result. Okay. Now, this one, we're talking about the D, right? So far, we have talked about Y changes, also X changes. But now, the D really doesn't change anything. Okay? So D is another X variable. Okay? So if you compare this Y1 and Y2, okay, this one should be Y3, okay? So, oh yes, it is Y2. Okay, if you compare with Y1 and Y2, how do you expect the relationship between alpha 2 and beta 2? Since this D is the same as this D, right? So only the difference is the Y multiplied 2.2 times. Therefore, since this multiplied 2.2 times, so the beta 2 also multiplied 2.2 times compared with the alpha 1. So what is our alpha 1 here? Inches and pounds and inches. So here. So this is our, here is our alpha 1. Alpha 1. Am I right?
Yes.
No, this is
This is
pounds. So here. So here, this beta 2 is 10.01273. So how do you expect the alpha 2?
Divided 2.2
Divided by
times. 2 times.
2.2, right? So you divided this one by 2.2, and it becomes to 4.55. Okay? Okay? However, if I compare Y2, this one and this one, this D and this D, this is the same Y, right? compare this one with this one. I have the same y, which is y2. And do I have the same d? Yes. So how do you expect the alpha 2 and the gamma 2? Since I don't change it, y2, I don't change d. I mean the measurement units. I don't change it. So alpha 2 is the same as gamma 2. So can you show this one?
Oh, we don't have.
This is gamma. This 4.55 is
Yeah.
this one, right? This one.
Centimeter.
Is this in
This
inches?
is for kilogram and centimeter.
Is
We
this
don't
in
have-
inches? No, centimeters.
centimeter.
Therefore, it's this one, right? So I should have alpha 2 equal to gamma 2. Then can you show this one? Do you have this output?
No, we don't have.
Okay. If you do the comparisons, this is why, you will not miss everything, right? Since you know what you are going to do, and if you know what you are going to expect for, so you should have the reports which show the difference between this one and this one, and shows that alpha 2 and gamma 2 are totally the same. Okay? All right? Okay, continue. Let's finish your presentation, then we take a break, okay? So, have you finished?
Yes.
You already finished? Okay. Okay, let me see the result. Okay, okay. Okay, thank you very much. Okay, let's take a break for a while.